Hello guys, welcome to my channel. Welcome to this presentation on Kafka, an introduction to the distributed streaming platform. We will explore the fundamentals of Kafka, its core concepts, architecture, and its significance in the world of real-time data streaming. Today's topics are: what is Kafka, topics and partitions, Kafka brokers, zookeeper, Kafka producers, Kafka consumer groups and dead letter topic. What is Kafka? Kafka is an open-source distributed streaming platform developed by the Apache Software Foundation. It is designed to handle high throughput, fault-tolerant, and scalable real-time data streaming. Kafka is widely used in various industries, including tech companies, finance, telecommunications, and more, to build scalable and reliable data processing pipelines. Its key features: publish-subscribe messaging system, distributed, real-time processing and fault-tolerant. It's initially developed by LinkedIn. It was open source in 2011 and became Apache Kafka in 2012. High performance, latency of less than 10 milliseconds, near to real-time. Used by the 2000 plus firms like LinkedIn, Netflix, Microsoft, Airbnb, Yahoo, Walmart. Netflix process 4, messages a day with Kafka, 1 trillion. Topics and partitions. What is topic in Kafka? It's a particular stream of data. A topic is identified by its name. We can have as many topics as we want. Data structure, example array. Producer and consumers subscribe to a topic. Topic partitions. Topics are split into partitions. Each partition is ordered. Each message within a partition gets an incremental ID, called offset. Have a look on diagram. Offset only have a meaning for a specific partition. Message on offset 3 in partition 1 is not equal to message on offset 3 in partition 2. Data is kept only for a limited time, default is 2 weeks. Once the data is written to a partition, it cannot be changed, immutability. Data is assigned randomly to a partition unless we provide partition key. We push data only to a topic, not partition. Kafka brokers. Kafka cluster is composed of multiple brokers. Each broker is identified with its ID. Each broker contains certain topic partitions. After connecting to any broker, we will be connected to entire cluster. In below diagram we have 3 brokers with 2 topic 1 which has 3 partitions and topic 2 which has 2 partitions. Understand below diagram to find how topic replication works. Here are 3 brokers with 1 topic which has 2 partitions and replication factor is 2. By any chance if we lost broker 2 then broker 1 and broker 3 can serve data. Concept of partition leader. At any time only one broker can be leader for a given partition. Only a leader can serve and receive data for a partition. The other brokers will synchronize data. Each topic partition has one leader and multiple in-sync replicas. Understand by below diagram. What Zookeeper does in Kafka? It manages brokers, keeps a list of them. Helps in performing leader election for partitions. Sends notifications to Kafka in case of following changes. Created new topic, broker dies, broker comes up, delete topic etc. Maintains configuration information. Usually operates in odd quorum e.g. 3, 5, 7. Has a leader, the rest of servers are followers. Tree-like data structure, e.g. Linux file system. Now let's take a closer look at Kafka producers. In Kafka, producers are responsible for publishing messages to Kafka topics. Only have to specify a topic name and one broker to connect. Kafka will automatically take care of routing data to the right broker and partition. Concept of acknowledgement. If acknowledgement is set 0, then producers won't wait for the acknowledgement, possible loss of data but high performance. If acknowledgement is set 1, then producers will wait only for leader acknowledgement, limited data loss but less performance as compared to acknowledgement 0. If acknowledgement is set all, then leader plus all replicas acknowledgement, no data loss but less performance as compared to acknowledgement 0 or 1. Partition key in Kafka. Producers can choose to send a key with message. If a key is sent, then the producer has the guarantee that all messages for that key will always go to the same partition. This enables guarantee ordering for a specific key. Partition equals hash of partition key % number of partitions. Have a look on below table. Now let's explore Kafka consumers, which play a crucial role in subscribing to topics and processing messages. Consumers enable applications to retrieve and consume data from Kafka in a scalable and efficient manner. Only have to specify the topic name and broker to connect. Kafka will take care of pulling data from right broker. Data is read and ordered for each partition. Data read from consumers in such way. Within the partition it reads sequentially. Across the partition it reads parallel, that means more partitions double equals more performance. Kafka consumer groups. Consumers can be organized into consumer groups. Each consumer within a group reads from a different partition of a topic, allowing for parallel processing of messages. This scalability feature enables multiple consumers to work together to process messages efficiently. Consumer offset concept. Kafka stores offset at which the consumer group has been reading. The offset commit live in a Kafka topic named _consumer_offsets. After version 0.9.x, offsets can be stored only in Kafka. When a consumer has processed data received from Kafka, it should be committing the offsets. If a consumer dies, it will be able to read back from where it left off. Thanks to consumer offsets concept, otherwise it has to read it from start. Dead letter topic queue. A dead letter topic, DLT, queue, also known as a dead letter queue, DLQ, is a concept commonly used in messaging systems, including Kafka. It is a special topic or queue where messages that cannot be processed or consumed successfully are sent for further analysis or handling. By default it's disabled, so we have to enable explicitly. Default queue name is error.destination.group. Thanks for watching this video. Please do like and subscribe my channel if you have not done yet.